This video will look at quadrilaterals, and in particular look at their definitions, symmetries, properties, and relationships. This flowchart on the right-hand side can be found in this week's assignments, and you should fill this in as we go along with the video. You can pause the video at any time to finish copying. Now in the flowchart we'll see that we're going to be looking at four types of quadrilaterals. Up top we have the parallelogram, below is the rhombus and the rectangle, and at the bottom is the square. Notice that each has their definition next to it. The parallelogram is the quadrilateral with opposite sides parallel. The rhombus is a quadrilateral with all sides congruent. The rectangle is a quadrilateral with 4 right angles, and the square is a quadrilateral with all sides congruent and 4 right angles. Now the way the flowchart works, anything that is below will have the properties of those that are above. For instance, the rhombus is going to be a parallelogram. All rhombi have opposite sides parallel. The rectangle being below the parallelogram means that all rectangles are also parallelograms. Every rectangle will have opposite sides parallel. To the bottom is the square. This means that all squares are rhombi, meaning that they have opposite sides congruent, or all sides congruent, and all squares have 4 right angles, meaning that all squares are rectangles. In addition, all squares are going to be parallelograms because all squares have opposite sides parallel. Now this next handout is the one that you should have filled in earlier this week, and it's based on our work from last week. Here we have the 4 quadrilaterals again, and we have their definitions. Again, the parallelogram, quadrilateral with opposite sides parallel. The rhombus, the quadrilateral with 4 congruent sides. The rectangle, the quadrilateral with 4 right angles. And the square, the quadrilateral with 4 congruent sides and 4 right angles. Now this also lists what kind of symmetry we have. The parallelogram, the only symmetry is a 180-degree rotational symmetry. It has no reflectional symmetry. The rhombus, because it is a parallelogram, has the 180 rotational symmetry. In addition, it also has reflectional symmetry. The lines of symmetry for the rhombus are the diagonals. There's 2 diagonals of a rhombus, and those are your lines of symmetry for reflectional symmetry. The rectangle, on the other hand, has the rotational symmetry from the parallelogram, but its line of symmetries are not the diagonals. Instead, the lines of symmetries of a rectangle are the segments that connect the midpoints of opposite sides. And there's 2 of those. Now the square is a parallelogram, a rectangle, and a rhombus, meaning it's going to have the properties of everything that is above it. The square actually has multiple rotational symmetries. Because it's a regular figure, it can use 90 degrees, 180 degrees, 270 degrees, and finally 360, taking it back to itself. Now its lines of symmetries come from both the rhombus and the rectangle. It has the diagonals from the rhombus, and it has the segments that connect the midpoints of opposite sides from the rectangle. So for the square, there's actually 4 lines of symmetry. Now, in the way the flowchart works, things that are below have the properties above, but those that are above do not necessarily have the properties below. All right, let's go through the quadrilaterals a little bit more detailed, and let's look at the parallelogram. Now, we know its definition is the quadrilateral with opposite sides parallel, which by extension means that opposite sides are parallel. The way we show that are the arrows. The single arrow and single arrow tell me that those 2 sides are parallel, and the double arrow at top and the double arrow at the bottom tell me those sides are parallel. The arrows are how we're going to denote parallel. For its symmetry, it's a 180-degree rotational symmetry, and it's about the center. The way you find the center of a parallelogram is it's the intersection of the diagonals. You draw on the 2 diagonals, and where they intersect, that's going to be the center for the rotational symmetry. Now, in addition to the definition, which is the quadrilateral with opposite sides parallel, there's some properties that follow. Now, the properties are not the definition, they're just characteristics. For the properties, in a parallelogram, opposite sides are congruent. The way we show that was with tick marks instead of arrows. So let me show that again. These sides that are yellow and these sides that were orange are going to be congruent. The congruent symbol is that symbol with the equal sign and the little tilde above it. Opposite angles are going to be congruent. So that means angles that are away from or across from each other are going to be the same measure. And lastly, the diagonals bisect each other. We use the tick marks to show the congruent lengths. Now, let's move to the rhombus. The rhombus is the quadrilateral with all sides congruent, which by extension means opposite sides are congruent. That is part of the properties that come from the parallelogram. Again, we use the tick marks to show congruent. Now with the rhombus, all 4 sides are going to be congruent. It has the 180 rotational symmetry, which again, for the rhombus, is found by drawing in the diagonals and finding the intersection point. Here we go. There's the diagonals that show the reflection between the sides. So we have these 2 types we have rotational symmetry here, and here we also have the reflectional symmetry. Okay, now that we have the definition and we have the symmetry, let's look at the properties. Because all rhombi are parallelograms, we still have the opposite sides congruent, but we also have opposite sides parallel. We have opposite angles are going to be congruent, and we have the diagonals bisect each other. Those are all properties from the parallelogram. In addition, with the rhombus, the diagonals are going to be perpendicular. The way we show that is the box to indicate a right angle. Lastly, the rhombus has diagonals that bisect the interior angles. So if we look at where the diagonals are, we'll see that we mark it with those little arcs showing that the angles have been bisected. That means cut in half equally. Now for the rectangle, we know that it's a quadrilateral with 4 right angles, which by extension means opposite angles are congruent from the parallelogram. We'll show that with the boxes to show right angles. It has the rotational symmetry, which comes from the properties of the parallelogram from above, so 180 rotational symmetry. But now the lines of symmetry are going to be found by connecting the midpoints of opposite sides. Where they meet, that's going to be the center. Now in addition, it still has the properties, now that we've looked at the definition in the symmetry, the properties of the parallelogram still continue. It has the opposite angles are congruent. Now it'll have opposite sides parallel. It'll still have opposite sides congruent. And the diagonals bisect each other. Now there's one other property of the rectangle that the parallelogram didn't have. In addition to this, on the rectangle, the diagonals are going to be congruent. Now this is not true of all parallelograms. And here's an example how we can see that. If we take one of those diagonals and rotate it, we'll see that it carries over to the other diagonal. Now let's turn our attention to the square. The square is going to have the properties of everything that came above. Now the definition of a square is simply the quadrilateral with all sides congruent and 4 right angles. Now by extension, that means that all sides are congruent, or sorry, opposite sides are congruent and opposite angles are congruent. Those are the properties of the things that came above it. And we can mark that with the tick mark to show the opposite, or so that all angles are, the tick marks will show all sides are congruent, and the right angle, the boxes, will show that the angles are right angles or opposite angles are congruent. Okay, as far as symmetry goes, it has the 90, 180, and 270 degree rotational symmetry. The 180 degree comes from the parallelogram, but because the square is the first of our regular figures that we're studying with quadrilaterals, it's the only regular quadrilateral, it has a 90, 180, and 270 degree rotational symmetry. It has 4 lines of symmetries. The diagonals from the rhombus and the ones that connect the midpoints of opposite sides from the rectangle. Therefore, it has 4 lines of symmetries. Now, as far as the properties go, we have the opposite sides congruent and the opposite angles are congruent from above. But in addition, opposite sides are parallel because it's a parallelogram. The diagonals bisect each other, again, because it's a parallelogram. The diagonals are perpendicular because they're also rhombi. The diagonals bisect the interior angles because it's a type of rhombus. And because all squares are rectangles, the diagonals are congruent. All right, so here's the whole flowchart filled in. You'll notice that the properties of those that are above will be found on anything that's below. So if you look at the properties of the parallelogram, you'll see that those same properties exist in the rhombus, the rectangle, and the square. If you look at the properties of the rhombus, you'll see that they exist below in the square. The square has the properties of all 3 of the figures that are above it. All right, if you didn't get a chance to finish filling everything in, pause the video and now fill it in. Thank you for watching, and hopefully it helps you understand the quadrilateral flowchart.